All right. So reasoning model interpretability. Okay. So like probably the right place to start is just like, what do I mean? And like, why is this its own category? So I mean specifically interpreting models where a bunch of sampling of tokens happens. This can just be like a non-reasoning model that does a long generation, but I think reasoning models have made this a much worse problem. And I think maybe a good place to start is like, why does sampling make this more cursed? And any guesses from people?
It's just like for things that could happen. And there could be like rare cases too that you are concerned about.
It's like bigger space, bigger output space.
Mhm.
You also have like the interactions between like prior tokens. It's more of an issue here.
Mhm. What do you mean by that?
Like there's dependencies between certain sentences, like in the Thought Anchors paper and previous
Mhm.
ones. And if you try and mess with it, then it might impact downstream behavior.
Okay, but like, why is this an issue? I mean, neurons depend on other neurons. If you mess with them, it will mess with later neurons, right? Seems fine.
Mm, because of the way it was trained, like in framing on of the task of providing like the chain of thought has a different behavior, unlike the normal LLMs have. So, like if you change just one token or sentence, it could have like a ripple effect bigger than it will have happened in normal models
Mhm.
because it will like how it was trained.
But like, why is the way that it's trained important?
No idea. Like,
L?
Oh, I was going to suggest another one, which is that you don't have access to the whole state, right? Like if you're producing the next token, you know kind of everything that's there. But if you're producing a long train of thought, like and you're making samples in between, you've made choices that have lost you access to a lot of like the possible paths.
Mhm. Yep. Yep, I like that. All right. So the way I think about it, why is this cursed? There's like more stuff, like bigger out of space. It's stochastic. You're kind of making there's like randomness at every step. Um, there is like an enormous space of possible rollouts you could get, and you're like choosing a specific path through it. But I think that much of the time, when you want to make a statement, you really want to make the statement about like the whole space, not just like a fraction of the space. Um, I kind of like poetically calling this chain of thought is the shadow cast by the distribution, where it's like you have this incredibly complicated space and then it is like collapsed into this one thing that people often treat as like the only thing. And I'm just like, no, no, this is not how this works. Um, and it's also discrete and non-differentiable, which means that if you want to like use something like a gradient-based attribution technique or like something that exploits linearity, you're fucked. And it also has like way, way higher serial depth. So by serial depth, I mean kind of how many sequential steps of computation can you have? Where a single forward pass is kind of like one or two a layer, basically. And models aren't very good at using these, so it's in practice way less than the number of layers. And this makes it difficult for models to do complicated things in one forward pass. But if you can have like a bunch of steps and then an output, and then a bunch more steps building on that previous output, etc., you can have like much deeper computation that can do much more complicated things. And yeah, so I think that, yeah, these just like introduce a bunch of challenges. And I also think that they are just like a much larger, being a much larger space means that many existing techniques will just kill you with the amount of data you get. So what are the advantages? I think that randomness makes attribution easier in a sense. Because hey, this is like one of the key ideas in thought anchors. If you want to understand what a sentence does, you can look at the probability the model get the answer right, conditioned on everything including the sentence, and condition everything not including the sentence. What is the chain? You can estimate this by like taking a bunch of robots. And if we were doing greedy sampling and it was totally deterministic, we don't really be able to I don't think that's really like clear analog to this. Like you could just write some additional text and replace the sentence with that, but now you've thrown the model off distribution, and this is like kind of messy. Any other advantages?
You can read it. It's
You can. It thinks in English
Or
for
no?
now. Maybe.
Some things in English, like R1, the first version, like
Mhm.
to interchangeably think in English and Chinese.
It thinks in English star. Any other ideas?
I guess it's like some sort of structure that like language imposes, kind of a sub point of the English.
Yeah. I think just like the fact that it's like sequential is kind of nice. Meaning there are like certain things that's going to enable. And yeah, probably it kind of sucks. But yeah, so in my opinion, the field is just kind of dropping the ball here. Where almost all of the papers on reasonable interpretability that I like, I have supervised, which is a bad vibe. Specifically, I think Thought Anchors was great, banger paper, and I think that maybe the like key ideas in here, this idea of resampling as just like a powerful thing you can do to attribute importance to sentences. I think another powerful idea is the idea that like causal graph of sentences is a useful thing to study. And I think this kind of comes from a deeper take of like the chain of thoughts is like the intermediate state of computation of a reasoning model. You can think of it as like the model plus chain of thoughts is a function that produces output. The intermediate state of this model is just like the chain of thought. And in the same way, that model layers are great and can be studied and give us insight about what's happening. Because they are the intermediate state of computation, and like not that much can happen in between them. Ditto, like bits of the chain of thought. It's not perfectly analogous, but I think it's surprisingly good enough. And why sentences? I don't know, kind of arbitrary. You basically just want a better level of abstraction than tokens. Paragraphs seemed a bit too big. I think you could totally imagine like turns of a conversation or cool calls or something being good level of abstraction. And like really what we care about is reasoning steps, but sentences kind of works. And yeah, I think that, what do I think? Yep. Another framing is that by having this causal graph of sentences, we can kind of import a bunch of the ideas from kind of causal intervention based circuit analysis on the causal graph of like model components or SE latents or whatever. Like you can ablate a sentence by just deleting it from history and then see how that changes the distribution of future sentences. And this is like an ablation. And in the same way that ablations are a bit cursed because you can throw them on all distribution, this is a bit cursed because you can throw the model of distribution, but empirically it seems to kind of work. You can also do things like change the prompt or like change a sentence to do the equivalent of activation patching. You can combine these, like you do activation patching and then you see how that's affected rather being correct to kind of get a softer, more continuous metric to measure small changes. And yeah, I think this is just like pretty useful toolkit, and also one that in their like SQL paper thought branches, they just kind of like use for a bunch of interesting things and extend. Like I already talked about the blackmail stuff. They had some very fun stuff looking into unfaithful chain of thought. Well, unfaithful, where I think this kind of underscores the idea that chain of thought is the intermediate state of computation. And it would be surprising if it didn't have useful info, where they found things like you give the model a hint, and then you look at if you remove the hint from the chain of thought after a certain number of sentences, does the model act like it would if given the hint, or does it go back to normal? And find that it's a, I don't know, somewhat gradual process. Or at least kind of like the hint has like a non-trivial effect, even if some things are like much more important than others. Which I find kind of surprising, and I think counter to like some of the unfaithful chain of thought narratives of like the chain of thought is useless, in which case it should not have this causal effect. I also think that yeah, they also had some fun results looking into resumes, and finding that like for like examples of the model exhibited some bias. There were like certain sentences that has a significant effect on the probability of hiring. Like the job description doesn't specify years, and maybe they are more senior. That would be bad. And they found that the model is, they found that like with certain races and genders, the model is more likely to say things like, they are overqualified and like not get them the job. And this is kind of cool. I feel like it is just not obvious that you should be able to get things like from chain of thought. You totally can. And the like fact that the mapping from the race to the sentence was like important was like not obvious. And this is found in like a kind of purely correlational way. I think that if there are ways to like better unpick exactly what the causal graph is on this sentence, this would be cool. But yeah. Any questions on that? Yeah.
Like these, like the rollouts and sampling tooling, it would be considered black box. Like the
Uh-huh.
the attention, I don't recall how they called the attention heads, the aggregation attention
Receiver heads.
receiver heads is the only
Mhm.
white boxy tooling that currently is being applied in reasoning models, or
Yeah, basically. I also think that the receiver heads were like kind of the least important part of the paper or something, and could have just been cut and it'd be fine. And yeah, I both hate the work as like black box methods work surprisingly well and are like surprisingly rich, and there's a lot we can get out of this. And also, surely white box has like something to teach us. And I definitely think that there are like exciting sprint projects in the neighborhood of like combining white box techniques with the thought anchors framework and like seeing what you can learn that is difficult. I also think there's just like lots of groundwork to be laid. Like why does the model, or like, yeah, I think that's also groundwork around why does the model, why is reasoning interp even needed? Like, is it needed? Can we find good examples of like, yep, if we were good at reasoning model interp, we would know the answer to this. We suck, so we don't. And I have like vague answers, like, well, I'd like to know what's happening with blackmail better, but I feel like not super satisfied with this. And I think that a mini project trying to just like ask questions about reasoning model behavior and then try to answer them and see which tools do and do not work could be like pretty damn cool. Yeah. So like another example of black box techniques or OP is this another Matt's paper called like base models know how to reason, thinking models learn when. The idea is basically, let's do model diffing on thinking models and the base models. What's actually learn? And it turns out that a lot of what's learned fits into a small handful of behaviors. And they're kind of like reasoning behaviors, like backtracking, recalling facts, asking yourself how certain you are, following plan, that kind of thing. And they discovered a bunch of this by looking at per token KL divergence between the two models, where they just like got a thinking model rollout and then also ran the base model over this and looked at on each token, how much do they agree about the next token? And kind of derived various categories of reasoning steps from this, found steering vectors in the base model for being good at these, and then basically made this hybrid model where they use the thinking model to say, should I steer the base model? And if so, to what? And e.g., they're like, well, the base model knows how to backtrack, but like when you should and should not backtrack is like kind of a complicated problem that it hasn't really figured out. But the thinking model's good at this, so I'll add the backtracking steering vector when this happens. And they got this ridiculous result. I'm not sure I fully believe of like on, well, this might not be in this copy, but like on QQQ, they recovered like 91% of the performance with this hybrid model. Unlike the other models, it was more like 20 to 50%. So don't really know what's up with this. But QWQ was like actually trained with, it's like actually went through reasoning RL training, while their other models were distillations. So that could make a difference. I don't know. Replicating this on Quen 3 could be fun. I have no idea if Quen 3 is good at this. If like Quen 3 was trained with distillation or like properly. Probably distillation. But maybe not like the biggest ones. But yeah. And like I think that a lot of the insights in this came from this black box technique of per token KL divergence, which is a great technique. And then some of the evidence came from adding steering vectors. Yeah. And this was by Konstantin and Ivan, who are both on Slack and can be pinged. But yeah, I think the like key takeaway from this paper for me is, so in some sense, I think it's not actually mysterious why reasoning models are better at e.g. maths. I think that what is instead mysterious is why normal models are not as good as thinking models if they can think for it. Because thinking longer gives you more compute, it gives you more serial depth. This all seems helpful. Seems like this should make models smarter. The middle lesson, more compute better. Why? And my best guess is that normal models just kind of get stuck in loops and they don't use the extra thinking time productively. But like with a bit of scaffolding, like, oh, you should backtrack now, or like, oh, you should like make a plan and you should recall facts. These models could like be pretty damn good. And it seems like a surprisingly large amount of at least what's learned in these basic reasoning models. I have no idea if this will replicate on like complicated reasoning models. If we can look at this and somewhat understand like words. I think that, yeah, you can kind of think of this as a reasoning model has internalized its own scaffold to do this itself. It's a very cool result. I like this statement. It feels like a good but simple insight. And so yeah, going back to like reasoning model interp, I kind of feel like it's a pretty wide open field, in my opinion. I feel like thought anchors, I think, have like a bunch of good ideas and is like a good starting point. But I feel like the study of how to interpret basically all frontier model, it's a wide space. I feel like there's so much we don't. The space of like possible exciting approaches should be wide, even if I don't really have that many good ideas that don't feel thought anchors flavored. Because I've just been thinking about it for a while. And I don't know, people just screwing around, people trying to unify this with existing white box techniques, people trying to see how well existing techniques work, people trying to do basic science to like gain insights behind those techniques, like what problems do we currently struggle to solve, that kind of thing. These all just seem like exciting and fruitful. Right? You all to take a minute to put a question or take in the chat. Cool. Yeah, so the else question, what are the remaining mysteries? I think that a lot of the remaining mysteries are like kind of just about AI psychology or something, which is like, how do these models actually work? Do they have goals? Do they have intentions? What is the right way to think about them? If I'm trying to take more of like a mechanistic perspective, how much is it even possible to say about, say, a prompt across all random seeds? It's kind of a pretty broad thing. Can we isolate key parts of this or not? Kind of unclear. Another question is, can we, yeah, I feel like when is it legit to read the chain of thought or not? It's like a pretty important question. I feel like, what do I think? There's like, how much can we get away with just finding a few key sentences or even key tokens and understanding where those came from? Versus like, you kind of have to try to understand the whole thing and it's really complicated. Just like, what's the functional form of the chain of thought circuits? And like, what's the right level of abstraction to think about them? That's an open question to me. Yeah, I think, I don't know, probably a bunch more. That's what's going to mind. Could there be white box techniques for reasoning models that can be applied to latent chain of thought models? Yep, that sure is my hope. And I think is one reason to be more excited about white box techniques than black box techniques. Though I think it seems pretty difficult to have like a purely white box technique. And yeah, like I think that chain of thought has a shelf life as a kind of interpretability tool. I think that over time, models are going to like realize that they can't say sketchy things in there, or they're going to just like optimize the shit out of them. So they stop talking in like normal English, or we're going to switch to like latent chain of thought. I think that some of the like thought anchorsy technique could still be helpful. E.g., yeah, I think things like, well, GPT-5 uses the word marinade. I don't know what the fuck's up with that, that how does the behavior change if you like have it or if you don't have it? Maybe things like this could also be helpful for latent chain of thought. I don't know. But yeah, I think that it's just sufficiently difficult to reason about what the like future things we're going to need to figure out how to interpret are, that just interpret the thing that we have feels like my best bet, even though this is kind of dissatisfying. But yeah, things like leaning into white box, I think, are like totally reasonable instructions to a teacher. Yes, I think that sparsity should totally be a goal of reasoning model circuit analysis. Oh yeah, I think just like back to Elle's question, just what is a good case study of a reasoning model circuit? It's a question. I don't know the answer. I'd like to know the answer. I think it's important. I think if I had like great case studies like this, it would help. I mean, the Thought Anchors paper provides the best one I've seen. Like trying to attack a maths problem, and yeah, being like, well, here are the key chunks of the chain of thought and how they link together and how it maps on to like the metrics and shit like that. Which is kind of cool. But I think there's more depth. Elle?
Question here is that like, well, in the same way the chain of thought is just like one sample from the whole distribution, like this analysis is one sample from like the whole distribution of like, there's like a larger circuit, right, of chains of thought. So I guess I'm curious, like, if it would be interesting or there would be some delta in like, you just look through a whole bunch of the chain of thought and you group things maybe semantically, and then you build something analogous to this, but it's not a line, but it's a tree.
If you could do that, that would be epic. I think that I expect it to be difficult, but it might be possible.
I mean, it is just like, you could only sample, it would only be sampling things to sort of.
Yeah. Well, like, you know, if you sample 100 things and you find like a compressed format that like explains all of them, and then you sample another 20 and they all fit into that thing, I'm like, seems good. Even if you sample 20 and only 15 fit into your thing, and so like, seems great. I feel like you can claim to have substantially explained this problem. But yeah, I think what do I think? It could be a fun mini project. I think there's like something interesting there. You know, if you want to take on a third mini project for the week. Aditya?
Yeah, I guess like a key like methodological point, I don't really see how to get around. It's like with normal circuit analysis, I can like actually evaluate how faithful my circuit is by just like manipulating the rest of the model. But like if I say like these 10 sentences have the highest counterfactual importance and they're like connected this way, then like it's like grammatically coherent to just like run the model with those. So see like how can you like get metrics for circuit analysis like you typically would in like a normal model? Sort of like a big like
Yeah. Great question. I mean, you can try just perturbing the other sentences so it's like logically incoherent, but it is grammatically coherent.
Yeah.
Or just like, you know, swap out nouns for alternative nouns that make grammatical sense or something. And just like see how many you can fuck with without breaking things. There is the problem that maybe it's just really fragile. And every way to do this just fails. But my answer is, I think that, yeah, I mean, seeing if there is like some ways we can gain insight here. I do think that just like perturbing each node in your circuit and seeing if it does anything is pretty reasonable. As a way of like getting some insight. You could also use resampling to find good counterfactuals for like other sentences. Like regenerate that sentence 20 times and then filter for the one that's most reasonable but semantically different and replace. No idea if that would work. Seems like a fun mini project. But yeah. All right. I think that is most of what I wanted to say about the big picture of Meetup. I don't have a ton to say about either of these two. I think that for applied interpretability, there's like some value to just kind of get in contact with reality and trying to like do useful real world things. But I feel like there's been enough of this that I feel like there needs to kind of be like a pretty good story of why the thing is interesting to make sense, and like why it ties into like other bigger picture considerations. Though I do think that just like, is there a way to get interpretability ideas as useful in production models today? It's like a pretty interesting question. And I don't know, it's about the extent where I have to say applied interp, unless anyone has any questions on it. Cool. And yeah, I feel like, I don't know, basic science is like a very broad catch-all question. And I don't have like a ton of great ideas here, but I do think that like, there are probably ideas I could be pitched on here, and there I'd be like, oh, it's a great idea. You should totally go do that. I think one category that seems plausibly exciting to me is trying to understand questions like why, with emergent misalignment, does it generalize to being a Nazi rather than like the intuitively simpler thing? Where I have the hypothesis that it is because models have some narrative-based prior over the world where things that are like narratively meaningful feel more intuitive to them, and thus like be a movie villain is like supernatural and easy to slip into. Write buggy code is less so, and so that from this perspective, fine tuning makes it want to slip into the most natural thing, which is evil movie villain. But if this is true, I feel like it should be very hard to come up with like other examples of this. Like I had some fellows trying this and like they go amazingly well. But yeah, I think that, what do I think? Yeah, I feel like just generally when something surprising happens, digging into it like is plausibly fruitful. So I will have opinions about any given form of surprising thing. Studying emergent misalignment also had the problem that loads of other people studying emergent misalignment because it's really sexy. Though I don't think anyone was like quite taking the angle I thought was most interesting. But yeah, all right. So going back to the list of North Stars, I think that's like a pretty obvious correspondence to basic science questions with neural networks. It's like giving feedback on like how aligned the AIs are and like helping iterate on and debug alignment schemes is pretty heavily related to science misalignment and studying how to make good alignment evals, or just otherwise provide good qualitative feedback. It's worth also noting that I think there's clear links to like interpretability agents. If you can like make an agent that figures out how misaligned your system is, that is in some ways like that is an alignment eval. Like maybe it's a good alignment eval. And yeah, the confidence we notice of the model knowing it does bad research. That's kind of like a mix of lie detection and broader AI psychology questions. Just like, how do you tell the model's intentions or knowledge? But I think it's like an unusually important application. And yeah, really touch on this one, which I think about white box control. Like, how can you tell if the model is trying to betray you? And in particular, can leveraging internals help you do this better? Which my answer is maybe. And I think that the like natural idea is to just use probes and maybe have like some kind of hierarchical monitor where you first have a probe. If the probe fires, then something more expensive but more accurate fires, like runs, etc. I don't really know if I think there's like a great sprint project here, but it does seem kind of important. I The reason I'm not sure there's a great sprint project is 'cause I'm not sure like what we don't know or like what the bottlenecks are exactly. There's kind of more just like a vibe of like, it seems like there's probably something here, I guess. But yeah. All right. I am going to call it a day there. Happy to take any closing questions. Oh,
Just like thinking through the like thought anchors, but in the distribution space more. I have a
Mhm.
question about that. I guess I'm thinking about like take a bunch of rollouts and then cluster them all semantically and like cluster each maybe sentence semantically. But it's like, yeah, like each sentence that appears in some rollout. But like maybe not worry about where specifically it appears. And then calculate like conditional probabilities of like, is some set like cluster appearing, what's the probability of then some other cluster appearing later? And then you would give a like weighted graph. And like, I think it's kind of plausible that like there would be some meaning in that. And that would be like once you've thrown out the like insisting on it being exact sequence order and just like use that it has happened later, that it could be like not terrible to compute. Um, I don't know. That's the idea as it is now. Do you have takes on that?
so I don't follow the details in that. The version of the idea that I was imagining would be, yeah, the version of the idea that like I would imagine is you kind of cluster sentences in like sentence embedding space, and then you just like make an enormous graph of clusters, and then you view each chain of thought as like a trajectory through that.
Yeah. Yeah.
And you see if you can talk about something like, I don't know, like a Markov style. Well, if you're in this distribution, in this node, here's the probability distribution over like next nodes,
Yeah.
and like
I
see how
guess,
it's predicted power simple models like this have.
yeah. I guess my like objection to that is like it feels very not Markovian because like of course what is earlier in the chain of thought is probably going to influence the later stuff, but like that is a reasonable approximation to start with too.
Yeah. Yeah. I mean, like one way to think about it is just like, well, what is a form of modeling it that lets you make non-trivial predictions about the future of the chain of thought from earlier bits on
Yeah.
new seeds? That would be like the mark of success. Yeah. My guess is that like there's going to be a lot of chaos and sentence level is going to be too fine grained. But if you took, say, the exact problem they studied in thought anchors and tried to like identify things at the like more granular level that they do, and see if you can like, I don't know, even answering basic questions like, well, if the thing goes through the first 3 nodes in this like zoomed out configuration, does it go through other nodes or something? Would be a start. And like, are there things that go through like arbitrary subsets of these nodes, things like that? And yeah, just kind of seeing if you can find any structure. Because like the null hypothesis is that it's like a chaotic clusterfuck. And this would be sad. I don't think it would be the end of the world. I think that I think that words. I think that like this kind of local circuit analysis where you just take a rollout and try to understand that rollout. It's like reasonable. Lewis?
Yeah, a pretty different question I have from the topic at hand, but perhaps related. Like, what are your thoughts on language concept models? Like trying to convert these sentences into concepts. Like,
What is a language concept model?
it was an idea, I think, from Jan LeCun from Meta to not tokenize it at the world level, but a concept level. There was some model I think they train on, and it has a pretty decent performance from the sides, but I haven't seen more papers on it. Um,
Let's see. So, presumably this paper?
Yeah.
We assume concepts correspond to sentences. What? I mean, there might be some interesting ideas here. I have not engaged with this idea at all, so I have no real takes.
yeah, I was
Um,
thinking like trying to explore like a latent vector space, but like in this kind of representation. So I was thinking on the rollouts being like a random, not random, but like a random walk that like with this stochastic
Yeah.
behavior, like traversing the vector space. But given the talking nature, the word by word, I feel like the trajectories wouldn't have meaning like in this in the normal vector space, in the latent vector space we work. So we would have to have like a concept based vector space for the
Mhm.
trajectories itself to have a meaningful meaning. I don't know.
So, I don't know. I think I think you're taking like a sentence embedding model that is concepts.
Yeah.
In a sense. Um, but yeah, I don't know. Like, I have no strong takes. My meta level advice is I think it's very easy to get extremely overcomplicated on something like this. And I think you should try to have like a clear what is the way that this will be superior if it works? How will I be able to tell if I have succeeded at this? And then go screw around with like a weird blue skies idea. But I think if you don't have that, then it's going to be very hard at the end of it to tell if you've made any progress or not. I don't know. You could like ping Paul and Uzai and be like, hey, what annoys you most about sentences? Or like, what would a superior alternative have? Or something. Yeah. All right. I think I will actually call it a day here. Thanks all for sticking through this like 12 hours of lectures.